Hello guys, welcome to my channel. So today in this video, we have this breast cancer data set. We will using this data set, we will explore and we will build a machine learning model which help us to find whether the person is diagnosed with malignant or benign. So in this video description, I will be providing my GitHub link so that from that you can find the code and the dataset. So now we'll be jumping over the coding section. So our problem is to classify to find whether the person has been detected with malignant or benign. So for that we'll be using the classification algorithm. So before building the machine learning model, we will try to explore the given data set. So for that, for exploring, I have used NumPy, Pandas. Then for visualization part, I have used Seaborn, and Matplot is optional. You can use Seaborn or Matplot. So I have imported the necessary libraries. Then I have Then I have started to explore the data set by reading the data set. Then getting the info about first five data from our given data set. Then I used a code to get to know about the column names, and after that I have removed some unnecessary columns which doesn't play a role in the insight process. So these are id and unnamed columns. So after removing those unnecessary columns, I have checked the null values, because these null values will affect our insight process. So in our data set, there is no null values. So if there is any null values, best way is to remove those null values. Some people try to replace it with the mean value, a central tendency, but the best way is to removing those null values. If you are replacing the null values, it affects our entire process of insights. So the best way to treat the null values is to remove those null values instead of replacing it with central tendencies. So after that, got the knowledge of like how much rows and columns in our data set. We have like 569 rows and 31 columns. So the first element will be rows, number of rows, and the second element will be number of columns. After that, I've used a code which is d types to get to know about the data type of each columns. So in our data set, we have except diagnosis, other columns are in the data type of float. So after that, I have drawn a bar chart as well as a pie chart to know about how much person has been diagnosed with malignant and how much person has been diagnosed with benign. So from our bar chart, we can come to a conclusion that many people has been diagnosed with benign. And after that I have drew the pie chart. So from the pie chart we can come to know that 63 percentage of people has been diagnosed with benign, and 37 people has been diagnosed with malignant. So after that have did correlation. So why we do correlation? So by doing correlation, we can come to know which are the columns has good relation and which are the columns has bad relation. So in a simpler term, which are the column has positive correlation, which are the column has negative correlator, which two column is not even related, doesn't have any relationship. So I have written a code for finding the correlation. So after that, from this, I have come to know, like for example, So the radius of mean and perimeter mean. So these two column has a positive correlation. As you can see, radius mean, perimeter mean. So in this table, radius mean and perimeter mean. So it's like 0.9. So it has a it is highly positive correlated. Not only these two columns, there are some columns which are positive correlated. Next is radius mean and area mean. So from this table, radius mean and area mean. So this is also positively correlated, highly positively correlated, which is 0.98. So like that, we have drawn a scatter plot to see its correlated. So as you can see, the line has been is being extended. If sorry, the line is going upwards. If this line goes downwards, means you can say that it's negatively correlated. So in every scatter plot, you can see that this line is moving upwards. So from that, you can conclude that it's highly, not highly, it's positively correlated. If instead of moving upward, if this line moves downward, we can say that it's negatively correlated. So like that, I have drawn scatter plot to know its relation, to see which other columns are positively correlated. So by doing scatter chart, we can get more visuals. Instead of from this table, you can't get a good visuals, or you can't get a good insight. So these charts, like why have used scatter chart means scatter plot means to get a good visuals. Um, yeah, to get a good visuals. Instead of not plotting scatter plot, and I'm showing this table to my client, he won't get an idea. We may know like which other columns are positively correlated, which other columns are negatively, but my client doesn't know or doesn't get any idea. He may get confused. So for that, we'll be showing this scatter plot. So to our clients, we'll be showing this scatter visuals to get so that he might get an idea. So that's why I have drawn this scatter plot to get a visual of this correlated table. So after that, I have drawn a scatter plot for negatively correlated. As you can see, this fractal dimension mean and radius mean are negatively correlated. We'll be seeing it in the table. Factoral. Wait a second. The column name is factoral dimension mean. Factoral dimension mean and radius mean. Factoral dimension mean and radius mean. As you can see, it's in negative, like it's in like minus 0.31. So it's negatively correlated. So these factoral, so as you can see, the line is moving downwards. As I said in earlier that if that line moves upward, it can be said as positively correlated. If the line moves downward, it can be said as negatively correlated. So like that, the radius mean and factoral dimension mean. Oh, sorry, I have drawn the same chart. The texture mean and factoral dimension mean. Here, the factoral dimension mean and radius mean has a is negatively correlated. Like that, factoral dimension mean is negatively correlated with texture mean. Wait a second. Factoral dimension mean and texture mean. As you can see, it's like minus 0.07. So it's negatively correlated. So like that, I have drawn some scatter plot for some of the negatively correlated columns. So after that, we'll be building our machine learning model. So as this problem is being solved using classification model, I've used four models which are logistic regression, decision tree, random forest, and KNN. So and I have used hyperparameter tuning. So why we used hyperparameter tuning? Because to, as you can see in our model, we have a list of parameters. So to find the best parameter among each model, we use this hyperparameter tuning. So the best for hyperparameter tuning, we will be using grid search CV. So we have cat, as you see above, like I have made a code for data type. In that, except one column, every columns are in numerical, which is I guess it's diagnosis column. Yeah, as you can see, the diagnosis column is in categorical value, but other columns are in numerical value. So before building, not before, our machine learning model can't understand some particular language. So if you're providing this categorical value in while training a model, it doesn't understand. So for that, we'll be converting this categorical value to a numerical value. So for that, I have used label encoder. So using label encoder, we'll be converting this categorical value to a numerical value. So as you can see, the diagnosis column, before doing label encoding, the diagnosis column has had a categorical value. After doing this label encoding part, it has turned the categorical value to numerical value. So you can see that it has been turned to numerical value. So after that, we'll be training our model. So for training our model, we'll be splitting our data set to train test and testing data set, train data set and testing data set. So using the train data set, we'll be training our model, and using the test data set, we'll be trying to test, like we'll be trying to find the score of our model. We'll be trying to predict our model. So I have used this train test split function to uh, split our data set to training data set and testing data set. So after that, I have used hyperparam. After that, I have used hyperparameter tuning for finding the best parameter in each model. So our first model will be decision tree classifier. So in decision tree classifier, we have like two parameter. Not there are some parameters, but I have used just two parameter. Like in criterion, we have like Gini, entropy, log loss, and in splitter we have like best random. So instead of trial and error, we can use this grid search CV to find among these three which is the best one, and among these two which is the best one. So after that, we have found the best parameter. So in criterion, among these three, the best parameter is entropy, and in splitter, the best parameter among these two is best. So using this two parameter, we started to train our data set by passing the train data set, and after training our model, we calculate the score of that model. So for we got a score like 92.98 percentage. So as of now, this is the highest score. So after that, we try to do prediction using the test data set. So after that, second model is random forest classifier. As I said before, the same process, hyperparameter grid search CV to find the best parameter. After that, finding the best parameter among this. No, no. After that, we printed the best parameter, and using that we try to train our model. We try to train our model. After that, we calculated the score of our model, and at last we try to predict. I'll show this step. So this is the step where I have used grid search CV to find which parameter is the best parameter. So after that, I have printed the best parameter. So in our case, this is like among these three, the best is entropy, not entropy, sorry, log loss. Yeah, log loss. After that, using this parameter log loss, I've trained our model by passing the trained data set. Yeah. Then after that, after training our model, calculate the score. So we got like 95 percentage. So this is the highest. Like in decision tree, we got like 92.98. But in random forest, we got like 95 percentage. So this is the highest. So after calculating the score, I have did prediction using by passing the test data set. So as of now, the model which has the highest accuracy is uh, random forest, which is 95 percentage. So after that, the next model is logistic regression, the same hyper grid search CV to find the best parameter. Then after that, printed the best parameter, so which is L2. So using this L2, using this parameter, uh, trained our model. So after training our model over the trained data set, I have calculated the score. So logistic regression, which has 92.1 percentage. So this is the least, because our random forest which gave accuracy like 95 percentage, then dysentery which gave accuracy like 92.98, but logistic regression gave accuracy of 92.1. So this is the least. As of now, this is the least accuracy, but 92 is not bad. It's a good accuracy, but among these three, this holds the least accuracy, which is 92.1 percentage. So after that, I did prediction. So now it's our last model, which is KNN classifier, the same grid search CV to find the best parameter. After that, after finding the best parameter, I have used this parameter to train our model by passing the train data set. After that, I have calculated the score. So this holds accuracy of 92.98. So this KNN model as well as dysentery classifier holds the same accuracy. Dysentery classifier also holds accuracy of 92.98, and KNN holds accuracy of 92.98. So both model has the same accuracy. After that, I have did prediction. So for this data set, I would suggest random forest classifier because it gave a high accuracy, which is 95 percentage. After that, you can use dysentery or KNN, which is 92.98, and after that, logistic regression. So that's it. Thank you.